So today we are going to talk about the chain rule. Okay class, are you ready? Let's start! Yes, teacher! Yes, teacher!
Yes.
Okay, first, Elena, could you tell us what is the chain rule?
In calculus, the chain rule is a formula for computing the derivative of the composition of two or more functions. That is, if f and g are functions, then the chain rule expresses the derivative of their composition fg in terms of the derivative of f and g and the product of functions as follows. Thus, this equation is the example.
Well done, Elena. You are really doing a good job. So everybody, listen up. You guys should learn to her, So here we go. Everybody already understand what the chain rule is. So let's now just move to the next part. Let's make some examples.
Alice, I want to sleep. I don't want some example.
Hey, Andrew, what are you doing? Shh.
The chain rule may be written in Leibniz notation in the following way. If a variable z depends on the variable y, which itself depends on the variable x, so that y and z are therefore dependent variables, then z variable the intermediate variable of y depends on x as well. The chain rule then states well like this. The two versions of the chain rule are related. If z equal to the y of f, and if y equal to the g of x, then we will get to this equation. In integration, the counterpart to the chain rule is the substitution rule.
Oh, that is the real meaning of the chain rule. Thank you, teacher. Thank you. I got it.
Oh my god, I don't want to sleep anymore. I understand.
Well done, Andrew. Keep working. Hey, teacher, I have questions. Pew, 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 pew. Andrew, shh. What are you doing, Andrew? As you got everything understanding, you just begin to bother everybody else. Are you? Now, Alice, could you continue your questions? Yes, teacher. Could you give us some tips for making us to avoid some mistake when we are doing some questions or solve some very big hard problem? Well done, Alice. This is a really good questions. Okay, everybody listen up. Now I'm going to teach you guys some tips. It's really important tips. You need to really understanding. Really remember that. You know that this is really important for your future life.
Let's restate the definition. Given a function f, the derivative of that function at a point x will be equals to this function. And listen up, everybody should really remember this equation because this just like a equation model, and it can be used for any of the problem you will be need to solve in this chapter. And let's solve the first example. And derivative of a constant. Let's calculate the derivative by definition of the simplest of functions, a constant, that is. We consider the f of x equal to c, and where c is a constant, there is only one thing to do. Apply the definition. As the function is constant, we have the x. We have this equation, and this implies that the difference in the number root of the definition equals 0. This makes the calculation really easy. We can see that. Let me give you 3 seconds to watch this. And then the derivative of a constant is 0. This is a very important fact that you will use all the time, and it makes intuitive sense also, both geometrically and physically. The derivative gives the rate of change of the function as the constant doesn't change. Its rate of change equals 0, and geometrically the graph of the constant function equals a straight horizontal line. Hence, its slope equals 0. And as we talk about the chain rule, we have to mention another very important concept, that is the implicit differentiation. And in calculus, a math called the implicit differentiation makes us of the chain rule to differentiate implicit and defined functions. To differentiate an implicit function f(x) defined by an equation r x y and equal to 0, it is not generally possible to solve it explicitly for y and then differentiate. Instead, one can totally differentiate and with respect to x and y, and then solve the resulting linear equation for dy divided by the dx, and to explicit get the derivative in terms of x and y, even when it is possible to explicitly solve the original equation. The formula resulting from totally differentiate and in generally much simpler and easier to use. And here are the 3 graphs, which is also very important related with the implicit differentiation. So let's see this graph first. And this graph, although not the graph of the function, it is the union of the graphs of 3 separate functions. And this one, the circle combines the graphs of 2 functions. The graph of y2 is the lower semicolon and passes through 3 and -4. This one is a derivative from the in example 1, gives the slope for the tangent lines at both P and Q, because it is a function of y. Shall we see this curve?
Oh, by the way, shall we just look a video first to have a better illustrate for you guys to about the chain rule?
I treat a derivative as something that you have to do to both sides. Weird, huh? But it works. Now, my goal here is to get dy over dx, so what I have to do is do the derivative with respect to x on both sides, like this. D over dx. I'm going to put this in a parenthesis because it has to be done to that entire side. Now, if I'm doing the derivative of one side, I have to do the derivative of the other side. So we've got d over dx of 5. Okay, now we can go to town. Here's something, though. It's a key component of it that's kind of brand new. We have to do y with respect to x. It's not even the same variable. Now, what you do, though, is you pretend that this is x for the time being, and you do its derivative. The derivative of y is 1, or derivative of a single variable is 1. But you don't really know how y relates to x. So effectively, this is actually like the chain rule. It's like y is composed of a bunch of x's, and there's a bunch of stuff in there, and you have to do its derivative as well. But I don't know how y relates to x, so I just have to leave that derivative unfinished. Like this, that. Now let's do the derivative of that. That's easy. -2x. We are almost done. Recognize that? That's just another way of saying the derivative. I'm going to solve for this fraction, and I'm finished. So let's see what we have here. We're going to add 2x to both sides. Nina. All right. In the next slide, I'm going to show you that this really mysterious technique really works. What I'm going to do is solve this for y and do it the way we normally did derivatives.
Now, after all of the concept, are you guys understanding what is the chain rule and the tapes and the examples? Do you understand? Yes, thank you, teacher.
Yes, teacher, yes.
Yes, teacher. Okay, our class is over. See you next time. See you. Bye, guys. Love you guys. Mwah. Actually, you know what is it? It is a prize. Now it's a pen. Oh, this person. As I imagine this person, I saw it about Andrew. And really, sometimes sleeping in the class. And it's really funny. Yes, I hope you like it. This person, I saw the original idea is come from the Lily. I think Lily is really good at studying. So she's a really good example for us. So I thought everybody should learn from her. And at last, I want to say, this is a really good project for we could do this way, like doing the project, doing the model, or doing the video, to let us to have a better understanding with the each concept we have learned. Thank you, Miss Lu. Thank you for teaching me for over a year. Thank you very much. Bye. Love you. Mwah.